Welcome to Robots as Partners, the new era of embodiment and exploration. In this episode, we spotlight rapid progress in robotics, featuring key findings from 18 recent research papers published on July 28, 2025. Today, we explore breakthroughs spanning human-robot teaming, embodiment, and intelligent adaptation. Join us as we journey into the future of intelligent machines and discover how robots are learning, adapting, and collaborating with humans. In this episode, we will dive into 18 leading robotics papers published on July 28, 2025, highlighting the latest advances in the field. The discussion will unveil core trends such as embodiment, sensing, learning, and the fusion of artificial intelligence with robotics. Expect an in-depth look at essential methods, including imitation learning, model predictive control, and hybrid AI approaches. 3 seminal works that are shaping the direction of robotics research will be spotlighted. Finally, we will envision the future of collaborative and adaptive robots as they become increasingly integral to society. Robotics stands at the intersection of mechanical engineering, electronics, computer science, and artificial intelligence. Modern robots are designed to sense, decide, and act within dynamic environments, moving far beyond their original roles in factory automation. Today's research focuses on enabling robots to collaborate safely and naturally with humans, tackling challenges in control, adaptation, and deployment in real-world settings. The evolution from industrial arms to ubiquitous intelligent agents underscores the multidisciplinary nature and societal impact of the field. The first major theme centers on human-robot interaction and embodiment. Lee and colleagues investigate how users adapt to wearable robotic prostheses, emphasizing the importance of bridging the gap between human perception and robotic motion. Chen and team demonstrate methods for teaching robots new skills by leveraging human demonstration videos, advancing the paradigm of imitation learning. The overarching goal is to create robots that not only feel like extensions of ourselves, but also learn intuitively from human guidance. Embodiment and natural learning remain central challenges in this research domain. The second theme addresses perception, sensing, and managing uncertainty in robotics. Robots must interpret noisy and complex environments to function effectively. Kang and collaborators focus on fusing multimodal LiDAR data for unified mapping, while Zhang and Solar Mora introduce advancements in tactile and visual perception systems. Ferroni's research delivers uncertainty-aware planning methods for handling liquids, a task fraught with unpredictability. A key concept throughout is model predictive control, which empowers robots to plan actions by simulating potential futures and choosing optimal responses in real time. The third theme highlights autonomy, adaptation, and exploration capabilities in robotics. Gao and associates present vehicles capable of both driving and flying, enabling robust exploration across varied terrains. Bakulin's research introduces vision-only navigation strategies using topological maps, while Jin's work provides large-scale datasets for benchmarking LiDAR inertial mapping systems. Nguyen's breakthrough enables real-time nonlinear control algorithms to run efficiently on small microcontrollers. Underpinning these advances is the use of foundation models, AI systems trained on vast datasets to provide flexible, adaptable intelligence for real-world robotic applications. The fourth theme reflects the fusion of advanced AI with robotics and examines the broader societal impact. Ben Airy and colleagues utilize diffusion models to enhance gyrocompassing accuracy. Merlot's research applies large language models for interactive plan refinement, improving the adaptability of robotic systems. Polapalli introduces robotics-based solutions for managing ecological challenges, while Surur demonstrates autonomous strawberry harvesting in agriculture. The integration of AI is significantly expanding the societal and collaborative roles of robots, enabling new applications and addressing pressing global issues. Key insights from these 18 papers reveal how technical gaps are being bridged and robotic capabilities expanded. Lee's research shows that users' perception often lags behind the actual motion achieved by robotic prostheses, highlighting a need for improved sensory feedback. Gao introduces bimodal vehicles that adaptively navigate complex terrains by switching between ground and aerial modes. Nguyen demonstrates that advanced control algorithms can now be deployed on minimal hardware, making sophisticated autonomy accessible for small-scale robots. Kang enables robust mapping in multi-robot systems by fusing heterogeneous sensor types. Collectively, these advances exemplify how the fusion of AI and robotics is yielding adaptable, real-world machines. A diverse array of research tools and methods is driving progress in robotics. Model Predictive Control, or MPC, allows robots to plan actions by simulating multiple future scenarios. Deep learning techniques extract meaningful patterns from visual, tactile, and language data, powering perception and interpretation. Hybrid neurosymbolic systems are being developed to combine the strengths of pattern recognition with logical reasoning, enhancing robustness and explainability. Large language models are increasingly aiding in reasoning and interactive planning. Additionally, physics-based simulation plays a crucial role in enabling robots to plan under uncertainty, particularly for tasks involving unpredictable or dynamic environments. The featured paper, Embodied Perception and Adaptation in Wearable Robotic Prostheses by Lee and colleagues, explores how users adapt both physically and mentally to robotic prostheses. The study introduces the SCOMO metric to measure perceived motion, revealing that while users' body image improves with practice, a persistent sensory gap remains. This finding underscores the necessity for richer feedback mechanisms in prosthesis design to enhance user embodiment. The work is recognized for its human-centered insights and its significant impact on advancing the embodiment of wearable robotics. In hierarchical planning for bimodal ground-flying vehicles in complex environments, Gao and team present a pioneering approach that combines driving and flying capabilities within a single autonomous vehicle. The system utilizes a hierarchical planning framework based on Monte Carlo tree search, enabling adaptive selection of driving or flying modes for optimal exploration. Experimental results demonstrate superior coverage and robustness compared to conventional systems. This research is highlighted for its advancement of autonomous exploration technologies and its potential applications in challenging and dynamic environments. The paper F-Mimic, Imitation of Fine-Grained Actions via Foundation Vision Language Models by Chen and colleagues, introduces a novel approach for robotic learning. By leveraging foundation models trained on extensive visual and language datasets, the system enables robots to learn intricate skills from only a few human demonstration videos. F-Mimic outperforms prior methods in both precision and adaptability, facilitating rapid skill transfer from human to robot. This work is selected for its contribution to increasing data efficiency and pushing the boundaries of imitation learning in robotics. Looking ahead, several key challenges and next steps emerge from the current research landscape. Enhancing sensory feedback remains vital for improving embodiment in wearable robotics. Data efficiency and the ability to generalize across diverse tasks are pressing needs in robot learning. Integration of neural and symbolic reasoning is expected to yield greater robustness and interpretability. Progress in collaborative. Multi-robot systems will enable effective operation in dynamic and large-scale environments. As robots increasingly enter everyday life, addressing ethical and societal impacts such as privacy, accountability, and the changing nature of work will become increasingly important. This synthesis was created using OpenAI GPT 4.1 for advanced language understanding, with TTS and image generation support provided by OpenAI tools. Human experts have reviewed the content to ensure depth and clarity. though minor oversights may remain. All references to research papers discussed are fully cited in this episode. By combining AI-driven analysis with human expertise, this review aims to deliver a balanced perspective on the latest developments in robotics. Thank you for joining the AI Frontiers community. Subscribe to our YouTube channel to stay updated on the latest breakthroughs in AI and robotics. Look forward to deep dives into cutting-edge research and participate in shaping the future of intelligent machines. In this podcast, we bring you the latest breakthroughs in computer science and AI straight from arXiv preprint server. From neural networks to quantum computing, we simplify complex research so you can stay ahead. Whether you are a developer, researcher, or tech enthusiast, AI Frontiers keeps you informed daily. Thanks for listening. If you enjoyed this episode, subscribe for daily updates. See you tomorrow with more cutting-edge AI insights. Disclaimer: this video uses arXiv preprint server content under its API terms of use. AI Frontiers is not affiliated with or endorsed by arXiv preprint server.